Okay, now we're ready to go. So thanks. I would like to talk about the Chiplet reference platform utilizing UCP bunch of wires. So my name is Fabian. I'm working for Fraunhofer. And what I present today is a combined work of Samsung, Cadence, and Fraunhofer. So what we are presenting today is to building a chiplet ecosystem that means working for you. So Samsung, Cadence, and Fraunhofer collaborate. So we establish a silicon-proven chiplet development platform that is utilizing OCP POV chiplet interface. And that means we are creating this platform to work with you. So that means we are creating this platform to enable you to work with this platform and attach your chiplet to that platform. So first, let's start with the first short overview on the partners that are involved in here. The first one is Fraunhofer. So Fraunhofer is the world's largest organization of applied research. That means based on customer requirements, we are creating demonstrators and showcases, and we bring that towards productification. And for myself, so I'm working in the research field of advanced packaging since more than 10 years. That means chiplets, antenna and package, and also 3D stacking. And for that, we are addressing the whole chain from starting from concept development, from design flows, up to design from high level up to low level implementation. And that means to enable you for rapid prototyping in that domain for advanced packaging. The next partner is Cadence. So Cadence is a leader in intelligent system design. Things familiar to most of you or all of you. So it's a merger of EDA, system design, and artificial intelligence to create an ecosystem that is utilizing design, the system, and to create an intelligent environment. And the third partner on that side is Samsung. Samsung is one of the world-leading foundries, mainly based with its fabs in Korea area, but also in the US and in China. So what would you like to address with this chiplet reference platform is to enable an ecosystem. That means to address the whole chain from design, starting with EDA enablement, design flows, but also to support you with design services. For that is, of course, required to have IP. That means we have foundational IP in that included, but we also can provide complex IP for dedicated blocks. And to bring all this together up to manufacturing. That means IC manufacturing, but also assembly and test from the whole chain. That means we're starting from integration, from the technology, and we have also the options to scale. So there are large partners involved with large fabrication facilities. That means from prototyping up to large-scale manufacturing. It's all involved in that. What are your benefits for that? Just shortly to be addressed is faster time to market. So we are creating this platform that you can attach your chiplet to. We are addressing a better performance in case of power. So we have proven IP included, for instance, and we lower the risk for the supply chain. So we have a proven platform solution that you can start your implementation with. We have proven silicon for the chiplet, and we have integrated flows for manufacturing and technology for that. So how we enable this chiplet ecosystem? We would like to look at the next slides. First, let's look at the chiplet block diagram that we're going to use. So we're using a Samsung 5nm process. So it's a mature process that is in full production. On the core sides, we have some dedicated controllers cores, and we have some processing cores. This is the Q8 vision core, and a neuromorphic processing unit, this NNA. Combine all these cores together with dedicated interfaces. So we have a DDR5 interface to attach memory to this, and we have a PCI 5 or 6 interface to have a controller and PHY interface for system integration. And of course, we have a bunch of wire die-to-die interface to connect this chiplet to another chiplet. And we have also memory included from that we're getting from a Swedish company called Synergic. So that's a more detailed view on the Chiplet system architecture. As a central bus, we're using an XE-bus for that. So we have dedicated compute units. So that is a vision core together with a neuromorphic core and a DDR5 interface. And we have the same processing unit on that side again. And we have here our generic controller units with the PCIe interface and our bunch of wire interface. So in the first step, we will create that as an SoC system. That means integrating all these cores on one IC, but with a dedicated chiplet interface to attach your chiplet to that platform. And in the next step, we are going to modify the system so that we are creating a chiplet for these as a separate instance. So what is the chiplet platform then? So it's flexible and custom. So we're starting from RTL design up to manufacturing, up to bring up and validation. So this is our single chiplet. And the first step on chiplet package, we are combining two versions of that in one chiplet package. That means we have a scalable type of package. We have all this, what is required for bring out boot is handled by the NX and LX core. And that means IP and design reuse will be used. So in the next step, it is possible for you and your chiplets to use that platform to attach your custom compute or AI accelerator chiplet to that platform, to use dedicated Samsung processors or others as you wish, and have a bunch of wire interface for that available. So it means that is true heterogeneous system integration. That means we are combining different technologies on one substrate. And that's the view then on the packaging perspective. This means we are going to produce a multi-die package where we have this central platform with a bunch of wire interface where you can attach your compute die to. We have the DDR5 interface that will have an additional DDR5 on this package. And we have a PCI interface to either connect to a PCIe interface externally or inside the board. So to give you an example on potential application case means first thing will be an off-the-shelf host system provided by Cadence, and we will have a plug solution then to attach your chiplet board as a daughter board to that board using PCIe. That means you have a platform that is available, firmware is available, we have existing code that is running on that. You can use Tensilica Vision and AI software demos that are available for that and bring up your firmware for that to generate whatever you are addressing with your application case. So to sum up, we would like to enable chiplet ecosystem to drive the industry. So we are going to generate a silicon-proven platform that is enabling customization, and based on this customization, you as customer can do your development on that. This is to enable innovation. This is to accelerate design. So every chiplet that is using a bunch of wire interface can be attached to that platform, and that means also lowering risk because you're using a fully validated platform to attach a chiplet to. And with that, all partners would like to help on building a dynamic ecosystem. So on Fraunhofer side, we are addressing design and IP. On Cadence side, IP, system and tooling. And Samsung side will be responsible in addressing topics of manufacturing and also manufacturing IC perspective, but also packaging. So that brings me to the end of the talk. Thanks for listening. We are open for questions, either now from the audience, but here also our contact details. If you have questions, you would like to use the platform or what else, then please come back to us. Contact details are there. Thanks.
Thank you, Fabian. Next, we're going to talk about known good dyes. And I think we've got a very interesting talk here around a NIC card, if I've got that right. Nope, that's the next one. Jürgen, good morning.